Okay, hello everyone. Today's session we go through module 11 to 13 IP addressing checkpoint exam, which like I've mentioned before, it's a very tricky checkpoint exam for a very tricky module 11, which I think is probably the most critical module for CCNA 1, if not the whole of your CCNA certification. So let's just quickly go through some of the questions and probably have a discussion and exchange of uh, messages, if I can say, just to see if people are understanding. Right. Number one, uh, can I get pencil? Number one, what is the prefix length notation for a subnet mask 224? I think we are past those easy stuff. Quick responses. I'm expecting quick responses. Now we are past this. C/27. Okay, /27. How do we get there? Very easy. How did we get there? So very easy. Let's use our table. Our table says we have 128. So these are the number of subnets. 128, 64, 32, 16, 8, 4, 2. Again, it's row of 1. We'll remove it later. So here we have number of hosts. So we can have 2, 4, 8, 16, 32, 64. Here we have 128. This one doesn't exist. Then we have our prefix length. Let's just call it prefix length. So our prefix length here is 25, 26, 27, 28, 29, 30, 31. Then lastly, we can have our mask as well, our subnet mask. Our subnet mask. So this table, don't be confused. This table is only used if you are given a /24 network and you want to subnet that. If you're working with a /24 network, then this is the table that you're going to use, and it only applies for a /24 network. If you get something else different, you need to translate this knowledge of getting to this table into how you get another one, probably, which is /16. But since in CCNA we focus mostly, I think you will mostly be given /24 networks to subnet. This is the table that you need to use. So for our subnet mask, if we have /24, this is 255, 255, 255, 0. If we have /25, I just call this /25 up to /31. If we have /25, it means we have one extra bit that we've used here. 1, 2, 3, 1, 2, 3, 4. This is /25 basically. If we take this 0 here and we expand it to 8 bits. So this is /25, meaning we have 255, 255, 255.128. That's where the subnet mask is coming from. Then if you have /26, this is /26. So it begins .192 /27, another bit borrowed, 192 plus 32. So this is 224 /16, 224 plus 16, 240 plus 8, no more slashes, dot, 248, 248 plus 4, 252 plus 2, 254. Is this correct? 248 plus 4, 252. I think this is correct. If not, we get there. So this table summarizes almost all, not all, almost most of the questions that we'll be answering with respect to IPv4 addressing. You see in the Open SSR. So if you manage to understand how to use this, you probably master how to subnet, how to create networks, how to identify the number of subnets that you need, how to use VLSN from this. So it's either you cram this or you know how we got these numbers into good to go. Now, going back to my questions, very easy. The first one was 224. So 224, if I come here, 224E, it's /27. That's how easy it is. /27. Let's go. How many valid host addresses are available on the IP subnet that is configured with a /26? I can come back here, /26. Where is our /26? /26 addresses. I think subnets. These are hosts, not subnets. 62. So these are subnets here. Here we have hosts. I think there's a vice versa. The same difference. So country by /26, we have 65 available maximum addresses that we're getting have. 64 minus 2, giving us a total of 62. That's where our answer came from. 62. Easy. Which subnet will be used if 5 host bits are available? 5 host bits, right, using a /24. 5 host bits, it means per 8, ekpesera 1, 2, 3, 4, 5, 6, 7, 8. 5 hosts available. 1, 2, 3, 4, 5. And all 5 are available. Right. The question asks, which subnet mask? So if 5 are available for the host, it means 3 have been borrowed. If 3 have been borrowed, it means 1, 2, 3. It means /27 basically. That means 3 host bits have been borrowed to form a network. So most probably answer it by 224 /27 don't be gonna and it's there. 224. Very easy. All right. Let's go to question number 4. How many okay, answers. I'm waiting for answers in the chat. Number 4. Right. Whilst waiting for answers, let me see. Network administrator subnet that network /24 into subnet with /26. How many equal size networks are created? C. How did we get to C? Right, we have a network. Let me see. Let's have another page. So we have a network. What does it say? It says 192.168.10.0. 192.168.10.0/24 submitted to /26. Okay, admin subnets the network into subnets with /26. How many equal size subnets are created? So how many subnets are created? How do you get that? We have come from 24 to 26. How many bits have been borrowed? Here we have 8 bits host. Here we have 6 bits. So that's 6. 2. Okay, we have 8 bits host. Here, how many bits for the host do we have? We have 6. 26 plus 6, yes, 6 bits host. It means we have borrowed 2 bits for the network. Proper 8 bits can have per 6 bits. It means we've borrowed 2 bits. Those solutions for subnetting. If you have 2 bits borrowed, it means you have 2 to the power of 2 subnets that can be created, which is 4 subnets. Or you can go back to table Redu. We just look at /26. How many subnets are created? 4. Very easy. You can also use the table. You see my questions. Like I said, most of my questions at here encounter, but my answers actually will come directly from that table. All right, let's go. Number 5, match the subnetworks to a host address that will be included within that subnetwork. All right, if we have a /32, my answers are correct there. All right, so this is how you look at, I think this can be very tricky to some. This is how you look at addresses, host addresses that belong to a network. So this end here, Tinema network ID, this Tinema host ID, my host addresses. This side is my host addresses. So you want to match which host addresses belong to the network. How do you identify that? You can always find the range. That's the easiest way. So if I look at a /27, if you up on 32.32 is /27. The next network ID in this /27, you say, we come back to our table, the test upon a /27 here. Kata /27, you see our block size is 32. So not going to one of the next network, then to go add the number 32. So if I come here, I add the 32, I get 64. Yeah. Get on. That's my charge. I get 64/27. The next one, 32, I get 96. So it means my addresses that belong to network 32 range actually over 33 kusvika 64, 63, 62 kusvika 62. That's why this one at which is range between 32 and 62. Then it is 63 this is a broadcast ID. I think Dosaka is still. No, it's not a broadcast ID. It depends on the network. It can be a broadcast ID. It depends on the network keep. But since ASR must /27 pan up, so for /27, this is a broadcast issue. That's why I said I want to match. Then if you look at 64, range is 64, over 65, uskapana 96, 95 broadcast, uskapana 94. So anything between 64, 5 and 94, it belongs here. 64 and 94, 68 belongs there. Easy. Then from 96, I can add 32 here. I get 128. 128. So my addresses range 97 to 128, 127 broadcast, 126 last address. 97 to 126. Where does 121 belong? It belongs between these numbers. That's why it belongs to this one. This one, 128, it's a network ID. That's why it doesn't have a match. I think knowledge here will be useful going forward, even up to Maskakuma exams. Right. Number 6, an administrator wants to create 4 subnetworks from the network address. What is the network address and subnet mask of the second usable subnet? So it's in a /24 or if we want to create 4 subnetworks, what do we do? Go back to the table. 4 subnetworks are. So if I want to create 4 subnetworks, I use 464/26. That's the number that I will use to subnet, meaning I can create 4 networks, each in 64 addresses, and the prefix length will be /26. Question again, just to be sure I'm doing it. What is the network address of the second subnet? Second usable subnet. Right, second usable subnet, do you want to say up? The first one will be 192.168. Is that 1.0? I think so. 1.0, yes. So the first network will be this one, /26. The first ID, the first subnet will be the same as the parent network. What will change is this. So no parent network, what has changed is this prefix length. So the next one will be the 64. You add this number here. The next one, 128. The next one, 192. This is the second one. So 192.168.1.64 is our network ID, and our mask. If we're using 26, our mask will be .192. Going back to our question, it means our answer is .192, this one, .192, this one, then the second one, that is .64. So answer is A. No. Easy. Number 7, how many bits must be borrowed from a host portion of an address to accommodate a router with 5 connected networks? So we have 5 networks, meaning 5 subnets. How many bits we will need to borrow? Quick answer. How many bits we will need to borrow so that we'll be able to have 5 subnets? Let me make a chart for this one quickly. I'm counting just a few seconds. If I don't get an answer, Toto Famba. 3, correct. How did you find the answer for that one? How can you find the answer for that one? All right, this is how. So if you want to create 5 subnets, or let me put it this way, 2 to the power of n is equals to number of subnets. What is n? N is the number of bits borrowed. Borrowed from where? Borrowed from the host portion to the network portion. So if I get 2 to the power of 3, I get 8. And from these 8, that's where my 5 subnets are. Because I answer 2 to the power of 2, I get 4. It means I don't have enough subnets, basically. So our answer here is 3, 7B. Number 8, how many host addresses are available on this network? Host addresses. To find the number of addresses available or the number of subnets available, the easiest way is to find the number of bits available. If they're available in the host portion, then you can find the number of host addresses. The bits available in the network portion, then you can find the number of subnets that can be created. So here it's in a /26. /26 basically means we have 26 bits that are on the network side. We have 6 left on the host portion. 2 to the power of 6 minus 2, probably that gives you a 30. I hope you don't answer wrong. D. Yeah. 62. I don't think so. /2 to the power of 6. Okay, 2 to the power of 5. So correct. 2 to the power of 6 is 64. So this one is correct. D. So that is /26. It means 6 bits 0 host portion. 2 to the power of 6 minus 2. Do over 62. Right. We move. Sharon was very much prepared for this one. Where is everyone else? Number 9, how many? So for this one, our answer is D. This question is very tricky. It's not that tricky, but you see someone who probably play around and use this answer, which is very much incorrect, because this answer represents the maximum number of addresses that we can have. However, from that maximum number of addresses, we have 2 which are not usable. One which is for the network and the other one which is for the broadcast. Not usable in the sense we cannot assign them to host devices. So that's why we always subtract -2. Right. Number 9. How many host addresses are available on the network 172.16.128.0 with a subnet mask? So this is our subnet mask. Right. This one is not a /24 now. We cannot use our table for this one. You need to think. You need to know where that table came from to get here. So how many host addresses? If you want to find the number of host addresses, first find the number of bits, host portion. That's the easiest way. So you identify the network portion and the host portion. How do you identify that? You use the subnet mask. So if I look at the subnet mask, 255, it means I have 8 bits here. 255, or let me put it here, 255, 255, 252. Let me put it here on the page. So we have 255, 255, 252.0. So this is the subnet mask. We use it to identify the host portion in the network portion. The network portion is the part which is all ones per subnet mask. So all ones is 8 by 1 up dot 8 by 1 up dot. Then from 252, how many ones do we have? 252 is 128, 192, 224, 240, 248, 252. 0, 1, 2, 3, 4, 5, 6, 7, 8. This is 252. I think we are past. I hope we are past that. So basically, this is 252. Then here we have 8 zeros, the last part, this part. So the network portion is the part in all ones. So how many ones do we have? We have 8 plus 8 plus 6. 252, correct, which is 8, 16, 22. So we have 22 ones. 22 ones, this is the network portion. We can call this network a slash 22 network, meaning we have 10 bits left for the host. 10 bits left for the host portion. If we want to find the number of host addresses left, you use those bits. So 2 to the power of 10 minus 2 is the number of addresses that we can have. 2 to the power of 10, is it not 1024? What is 2048? Let me see. 2 to the power of 10, 1024. 1024. Right. 1024 minus 2, 1022. That's how we get to our answer right here. All right, we move. Number 10. Match the IP address to the appropriate category. Right, host addresses. How do you find how do you identify host addresses, or how do you differentiate them from network addresses? Host addresses, network addresses. Very easy. So if I look at this, it's a host address. How? You look at the subnet mask. You look at the prefix length. So if our subnet mask is /25, /25 means the first 25 bits are used for the network portion. All ones. First 25 bits, all ones, they're being used for the network portion. So if we have all ones, this 192 remains the same. Well, let me get it here. So we explain using that one, and for the rest, we don't explain anything. So for this one, I saw 192, I saw 168, I saw 161. What was in between? 100/25. So 100/25. Identify if that is a network or a host address. So you look at this number. This number basically means we have 255, all ones here. Let me do this. 8 ones, 8 ones, 25, 8 ones here, making a total of 24. Then only 1 bit here is used for the network portion, banner, right? 1 bit what does that represent for the network? Something like this, which is 128, meaning 128 is our network ID. Basically, 120 is our network ID. Therefore, 161 is a host ID. 128, can I trip a /25? I think we add another 128, which can be a network in English as 0 as well. So .0 is our other network. 128 is our other network R2. That's /25. I think I'm taking the longer route so that we explain this overcook. But /25-ish. My networks at no E2, two more subnets, each in 128 hosts. So you can see panap network irushanda up and the E in .128. That's network IT. Then 161 is just part of this network. That's how you identify. Or you can do this. Or you can do this. Right, let me see. /25 ngativhene izvostabva the network side. Let's come from the host side. /25 means you have 7 bits. It's the host portion. 32 minus 25. Exactly. 7 bits to the host portion. Meaning these are all zeros. Right. Ndikauya address E, the last part in 161. 161 anorepresentwa nani? 161 anorepresentwa na 128 plus 64, no, plus 32, 128 plus 32, 160. Right. 1, 2, 10 minutes, 1, 2, 4. I think this is 161. 161. Then all zeros per 7 bits. 1, 2, 3, 4, 5, 6, 7. These are all zeros. So as I get my zeros, we get again 128.128. Meaning this is a host portion because it does not match this address here network, basically. So let's look at the others now. That's why it matches up. Let's look at others. 191. 191, why is it a broadcast? Let's go about broadcast. Let's look at 199, 191/26. So .1, 191. Let's look at why it's a broadcast. 192, I think that would be the last one. 168.1.191/26. Why is it a broadcast? All right, if you are looking at /26 networks, I can easily go here. Let's start with our table. Let's make it easy for ourselves. /26. /26. Yeah, it's /27. All right, /26, 464/26. 464/26. 464/26. So if I'm using /26, the networks that I'm going to create, achatangira pana .0, .64, .192, .128, then .192. Those are the networks that I'm going to create, basically. So ndikauya panapa ndikata address E. It's a network. This one is a network. 191 panapa is a broadcast because I have 192 panapa. So as long as I'm using /26, my networks are under 1 and I. Then I can easily identify what broadcast if I look at this number. I got to just subtract 1 from the network ID and you get the broadcast. So 191 broadcast, 127 broadcast, 63 broadcast as well. 63 broadcast your network ish. 127 broadcast your network ish. 191 broadcast your network ish. Then broadcast here 192 is 255. Easy. That's how you identify what broadcast you're gonna teach. Let's look at. Can we make it one more? Your network. Because your host Tabata, your broadcast Tabata, your network. 10, 10, 10, 128. Right, 10, 10, 10, 128. 10, 10, 10, 128/25. Right. /25, it means the first 25 bits are zeros. Or let's use the simple method first. If I have /25, possibly we'll go /24. So anything to go /24, we end up /31. To refer to table basically, of which /25 belongs in between up. We have a table pan up. We got as /25 here. You know that I can create 2 subnets, 128 /25, 2 128/25. So I can say 2, 128/25. So if I have a /25, these are the numbers that I'm going to use. My networks ndinowana dot 0 ne dot 128. Of which dot 128 ndoirapo. Basically, it means that's the network ID. Simple. Ndichishandisa table. But let's say question yaisakwanisashandisika table. How do you know it is the network ID? I look at this number, /25. First 25 bits or ones, the rest are zeros. If the address that I get after that is the same as this one, therefore it's the network ID. So this number remains 10 because we have all ones. This number remains 10 because we have all ones. This one 10, we have all ones. Now we have 24 ones. That's our name 1. 1 each of a. So we just need one panel. So 128, the guys have my bits. What do I get? I get 128. This is 128. 1, 2, 3, 4. 128. And 1 bit, which is this one, one. It corresponds to 128. So everything else, and this number corresponds to 128. This number is the same as this one, therefore it's the network ID, basically. That's how you identify if an address is the network ID or not. But network ID, I feel like having another question. Let's look at the other one as network 172.110.12.64. 172.110.12.64. 172.110. I had 12 and the 64. I think it's 110. So correct. Exactly 110.12.64/28. /28. Right. If you get a number /28, then you can use the table. Any number between /24 to /25 to /31, you can use the table. In the table, /28, I think is 1616. It should be 16. Let me confirm. It should be 161628. So 161628. The networks that I get, .0.16.32.48.64/28 each 64/28. Therefore, it's the network ID. Using the table, very easy. Using a bit more complicated way can also resolve it. It can also resolve it. It's not that complicated. /28 means first 28 bits, therefore the network. And pese panema 1, 8 ones here, 8 ones here, 8 ones here. Pese panema 1, it means that part remains the same. That's why I'm going to drop and over up 172, 110, 12. Then tapa 24. Kwasara 4. So panapa, because only 4 bits are being used. So to break it down, kuisa binary, 64 is 0, 1, 1, 2, 3, 4, 5, 6. That's 64 in binary. Then the first 4 bits, ndopa number 1 up. Ndo achadzoka up, ndopa achadzoka pakadaro 0, 1, 0, 0. Then question kuchaita ma0, which there were zeros already. 1, 2, 3, 4. This number inongodzoka ita 64. Since yafanana neirokwi, ndozvinongoreva kuti network ID. Dai panapa pana 67, for example. How we identify kuti host is by doing the same thing. Ma1 aya anodzosa 172, 110 at 12. Panapa ma1 anenge ari panapa ari 4, 1, 2, 3, 4. Hapasina 8. Anodzosa 64. Akadzosa 64 tikakompare namba yatiri kuwana apa neyatiri kuwana panapa dzikangosiyana, it means in ichi host. Dzikangofanana, it means that's the network ID basically. Right, let's continue with our questions. Oh, 1 minute left. I think I can manage one more session. What 3 blocks of addresses are defined by RFC 1918 for private network use? Right. So we have this one private, this one private, This one private. Those two are private. And then I use this to identify them. 10/8, 172, 16/12, 192, 168/16. Doing private IP addresses. Very simple. Let's go. The fate of exhibit. Administrator sends a message to everyone, must send a message to everyone on the router. What is the broadcast address for the network? Everyone on the router. Network here in /22. Can I /22? You cannot use the table. Pagoda understanding in network. How do you manipulate my IP addresses? Could you run the broadcast ID up? With less than 1 minute left, I think let me stop here and I continue with video number 2.